Nephrons we have shown. Is it clear? Is it necessary to view the structure of the nephrons? This is part of the nephrons showing efferent arteriole, glomerulus. That means glomerular capillaries and tubular, Bowman's capsule, tubular portion of proximal tubule. Okay, the blood that is entering into the glomerulus through the afferent arteriole. This is the glomerulus where filtration takes place, filtration of plasma. Then this the glomerular filtrate arises, blood passes from the afferent arteriole through the glomerular capillaries, and then efferent arteriole. This is the pathway of the passage of the bloods. That means 80% of the entry of the blood in afferent arteriole is destined to flow through the efferent arteriole. 20% that remains, that 20% is being filtered in the glomerulus, in the glomerular capillaries, and from this, the glomerular filtrate is formed. That glomerular filtrate ultimately passes through the tubules. Is it clear? It passes through the tubule. Ultimate purpose is for reabsorption of necessary nutrients and secretion as well as excretion of the wastes. Is it clear? Ultimately leading to the urine formation. As a student number is, I find this very less. That's why I made a bit delay. Okay. Now we will be proceeding a bit forward. Okay. Now let us come to the figure point, basic facts. Some basic facts you must know about the urine formation. Number one, urine is formed from glomerular filtrate. This is the fact. Formation of urine is the coordinated effort of glomerular filtration, tubular reabsorption, and secretion and excretion from the tubules. Excretion from the tubules. Urine is excreted ultimately. Important changes that occur during these processes include change in pH. You think pH of blood, pH of glomerular filtrate, that is normal pH of the body. That means 7.4, average 7.4, 7.35 to 7.4. This is the pH of the body. This pH turns acidic in urine. Urine is acidic. What is the pH of urine? pH of urine is 6.4 to 6.7, like this. Okay. So definitely, if it is below 7, then it is acidic. If it is below 7, then it is acidic. Then the change in pH occurs during this process, during the process of formation of urine. One is change of pH, change in osmolality. Osmolality of urine is usually that means in concentrated urine. Usually urine that we pass, that is concentrated, is much more. Osmolarity of the plasma, we know it is 300 milliosmol per liter, but osmolarity of the urine, concentrated urine, could be 1200 uh, millimole per liter, 1200 milliosmol per liter, 1200 milliosmol. Then this pH again could be, then this the osmolarity could be decreased much. It could be decreased as low as 150 millimole per liter. 150. Is it clear? When I take large quantities of water, urine becomes dilute. On taking water, the urine is dilute urine. If someone body takes large quantities of water, then urine becomes dilute. So changes in osmolarity occurs, and that is very variable. It ranges from hypoosmolarity to hyperosmolar region. Usually, the urine is concentrated. That means concentrated means it is osmolarity is more than that of plasma. Increase in the toxic substance in plasma, the toxic substances if present, that is either absent or very negligible, but it increases in urine. It increases in urine. Okay,
স্যার
toxicity.
আসসালামু আলাইকুম।
Huh? Yes.
স্যার
Tell me.
কয়েকজন ওয়েটিং এ আছে।
ওয়েটিং
স্যার
এ তো
কয়েকজন
এন্ট্রি
ওয়েটিং
করা
আছে।
হচ্ছে, এন্ট্রি তো একবার করা হলো, খালি যদি এন্ট্রি কোথায় এখন তো পাওয়া যাচ্ছে না আবার। ওয়েটিং
না
এ
স্যার
থাকলে
গ্রুপে বলা হয়েছে।
যারা ওয়েটিং এ ছিল তাদেরকে মানে এন্ট্রি করা হয়েছে, এই যে এসছে। আমি যাদের পাচ্ছি কয়জন, না একজন মাত্র, একজন। তো এদের উচিত
ঠিক
সবাই
আছে।
ডিউ সময় ঢোকা আর কি, ডিউ সময় ঢোকা, তাহলে সুবিধা হয়ে যায়। আচ্ছা, তাহলে চেঞ্জ ইন pH occurs, change in osmolality occurs, increase in concentration of toxic substances. These three basic changes occur during urine formation. Okay, next. Next, this picture we discussed about it. It is not necessary. Here the first formation, this filtration, glomerular filtration, then reabsorption, secretion, followed by excretion. Okay. Now come to the point. As we saw, glomerulus. What is glomerulus? This glomerulus is a tuft of capillaries, about 50 capillaries, encased by Bowman's capsule. The capillaries are supplied by the afferent arteriole and drained by a slightly smaller efferent arteriole. Is it clear? Afferent means the blood entering into the glomerulus, and in glomerulus filtration takes place. Only few percentage, only 1/5, 1/5 of the blood is filtered, and rest 4/5 passes through the efferent arteriole. This happens generally. This could be varied. Anyway, then the dilated and blind end of the renal tubule encasing the glomerulus termed as Bowman's capsule. This yellowish portion, this is the Bowman's capsule. The reddish, this is the glomerulus. The Bowman's capsule encases the glomerulus. Okay. Then glomerular capillaries act as filters permeable to low molecular weight substances and water. These glomerular capillaries in other parts of the body, excepting kidneys, the capillaries are called exchange vessels. But in glomerular, but in kidney, these are called, its function is filtration. Okay, So glomerular function of the glomerular capillaries, main function of the glomerular capillaries are filtration. Filtration of what? Filtration of plasma. Okay? Filtration of plasma. Okay? Next, these are the basics. The glomerular membrane, you should know about it. The glomerular membrane uh, consists of the following parts: capillary endothelium, then glomerular basement membrane, then capillary then epithelial cells with food processes of visceral layer of Bowman's capsule, podocytes. Okay, so glomerular membrane consists of capillaries, capillary endothelium. This is on the side of the uh, that is the inner aspect of the capillaries. Then this capillary endothelium rests on basement membrane. Then the next the portion is the next constituent of the membrane is epithelial cells of the food processes Bowman's capsule. That means when the plasma is filtered, it passes through the ports of the capillaries, then basement membrane, then it enters into the Bowman's capsule by passing through the podocytes. Permeability of the glomerular membrane is determined by size, charge, shape. Size, if the size is large, it cannot pass through the glomerular membrane. It's low molecular weight substance can pass through. Molecular weight less than that of albumin can pass through the glomerular capillaries. Then again comes the question of charge. The glomerular capillaries, the healthy glomerular capillaries are negatively charged. And because of this charge, cells, that means red cells, which are also negatively charged, WBC cells, and protein, which are negatively charged, it cannot pass through it. Okay? So proteins cannot pass because of its large size, because of its negative charge. Negative charge repels negative charge. And this permeability also depends to some extent on shape. On shape. Okay? Next. Next. After this, we enter into the main topics, urine formation. Somebody is trying to enter, I don't know. Is trying. Okay. Okay, let her try. So urine formation, the urine formation, glomerular filtration is the first step of urine formation. It is an ultrafiltration process. Ultrafiltration means low molecular weight substances are allowed to pass through the glomerular membrane and high molecular weight substances are retained. Is it clear? It is it the filtration? The first step of urine formation is glomerular filtration. Is it clear? And this filtration is the ultrafiltration process, allowing low molecular weight substances to pass through it and high molecular weight substances are retained. That means proteins are retained. Proteins cannot pass through. Even albumin cannot pass through. because albumin is negatively charged. These capillaries are also negatively charged, so they repel each other. Albumin cannot usually pass in healthy states, but it can pass when there is disease, when the membrane becomes positive in infections, then it can pass. That is another thing, that is pathological condition. Next, after glomerular filtration, the next step is tubular reabsorption and secretion. Tubular reabsorption, and this tubular reabsorption and secretion, proximal tubule is plays very important role. Proximal tubule is called because it remains proximal to the Bowman's capsule. Is it clear? Proximal tubular reabsorption is obligatory and isoosmotic. Obligatory, that means the absorption here is not affected by any factors including hormones. Is it clear? There is no influence of hormones in the tubular reabsorption in proximal tubules. That's why proximal tubular reabsorption is obligatory. It is again isosmotic. Why isosmotic? It is isosmotic, that means equal quantities of nutrient and water. Equal quantities, that means almost uh, nutrients, 70% of the electrolytes and nutrient and almost all nutrients are reabsorbed, and 70% of water is also reabsorbed. Is it clear? Regarding nutrients, I'm coming. 70 first thing is 70% of the reabsorption takes place in the proximal tubule. Okay, electrolytes and water, both electrolytes and waters are 70% reabsorbed. Okay, 70% electrolytes are actively reabsorbed, then 70% of the water is passively reabsorbed. So the osmolality in the glomerular filtrate in proximal tubule remains the same. Regarding the nutrients, yes, nutrients are reabsorbed completely. Nutrients are reabsorbed. That, as for example, glucose, amino acid, then vitamins, then bicarbonate. These are 100%, almost 100% reabsorbed. 100% reabsorbed. Okay, and overall reabsorption I mentioned 70% this solutes and 70% water, and as the percentage remains same, so osmolarity remains, do not change. So glomerular filtrate in proximal convoluted tubule is same that of plasma, same that's as that of plasma. That's why it is called isoosmotic. Okay, distal tubular reabsorption is then remaining electrolyte water. After reabsorption 70% reabsorption electrolyte water, there remains 30% electrolyte and water are into the enter into the rest of the tubule. Is it clear? Rest of the, that means in the ascending limb of the lobe of the Henle. Okay, this is pictures. this this is a good picture. This is also more simplified. This picture is very simplified. Here filtration takes place. In this, after filtration, the 70% is reabsorbed in the proximal tubule, proximal convoluted portion. This then straight for proximal tubule. 70% of the electrolyte water is reabsorbed in the proximal tubule. Remaining 30% enter into the loop of Henle. First descending limb of the loop of Henle, then ascending limb of the loop of Henle, then it enters into the distal tubule. First distal convoluted tubule, and this distal convoluted tubule ultimately enters into the through the connecting tubule. It enters into the collecting duct. Collecting duct. This is collecting duct. Okay, this is very simplified, and this is a good picture which is showing the flow of the glomerular filtrate. The flow of the glomerular filtrate. Okay, the post electrolytes and water that is reabsorbed in the tubules in the proximal tubule and other portion of the tubule ultimately enters in peritubular capillaries. Through the peritubular capillaries, they are returned to the venous system. Okay. Okay. Then again come to the point. We also discussed this. I think this have been discussed. What substances are 100% reabsorbed? Completely reabsorbed substances are glucose, amino acid, vitamin, bicarbonate. Okay, this is the important one. This was shown. That's why I am not giving stress on it. Okay. Next. Uh, distal tubular reabsorption is facultative. Facultative means under the influence of hormones. This varies and it depends on the osmolality of the glomerular filtrate. Is it clear? This is variable and under the influence of hormones, as for example, aldosterone, ADH, atrial natriuretic peptide. These hormones influence the absorption of the nutrients. Now, the electrolytes, and main electrolyte is sodium. Main electrolyte is sodium. Is it clear? So, facultative reabsorption means the reabsorption that occurs under the influence of hormones can be termed as facultative reabsorption. Facultative reabsorption takes place in the mostly in the collecting duct and then distal part of the distal tubule. This is important to remember. And metabolic wastes, organic and inorganic toxins are secreted. The body, as a result of metabolism, the metabolic wastes are produced, which are which can be which are lethal for the body, which can create problem for the body. These are removed through the kidneys, and particularly if it is water soluble, then it is released through the kidneys, and this could be there could be toxins. The toxins, how these toxins comes? Suppose the foods that we take, these are these foods which are not free from chemicals. These chemicals which is detrimental to the body, and the chemicals that are produced in the body uh, are eliminated. Suppose in water there could be mercuries. These mercuries are eliminated. Okay, so this is about the fact. Excess electrolyte, even excess electrolytes, if say that sodium is reabsorbed, and if this sodium is excess, that sodium can be eliminated. Excess water is also eliminated. Okay, percentage is being given. Okay, don't this late entry. Who is Rohit? Late entry is, it is very bad. Okay. Okay. Excess electrolyte and metabolic waste, toxic substances are eliminated through the tubules. Excretion. Then after secretion, tubular reabsorption. First step was glomerular filtration. Next step is tubular reabsorption and secretion, and it is and then third step is excretion. Ultimately, substances which are toxic for the body, which can create problem for the body, or which are excess, that is eliminated through the urine, that is called excretion. Metabolic waste, toxic substances, excess electrolyte water are excreted in the urine. There is difference between secretion and excretion. If it is secretion, that means that is being secreted from the lining epithelium, and in the tubule it will act, it may have some effects, and ultimately it can be reabsorbed, or it can be eliminated. And this ultimate eliminate process of elimination is called excretion. Excretion. So means you understand the difference between secretion and excretion. Okay, excretion means total elimination from the body, and secretion means that is a gastric juice. And gastric juice, this is secreted, it is secreted for formation of the bolus in the kidneys. Here there is secretion of hydrogen ion. Hydrogen ion is secreted for reabsorption of the bicarbonate ions. Is it clear? Next. So in short, this is urine formation. I have not done is much elaborative, but this in this urine formation, you must know the previous subject, at least this basics, as well as these informations. You must know what substances are 100% completely reabsorbed, what substances are uh, secreted, and what are the excretable products. So this is, I am repeating it again. There is a picture also. This picture is not a bit good. The glomerulus, its function is to filter. Okay. After filtration, the glomerular filtrate is formed, which is an ultrafiltrate. It contains the glucose Amino acids, vitamins, bicarbonates in it are completely reabsorbed. These are not allowed to pass. Is it clear? In healthy subjects, it is not allowed to pass. And 70% of sodium, 90% potassium are reabsorbed in the proximal tubule. On average, 70% of electrolyte and water is reabsorbed in the proximal tubule. Reabsorption of the electrolyte takes place by active process, and this active process is followed by passive reabsorption of water. After 70% of electrolytes and are reabsorbed, potassium is also no, the water is also reabsorbed passively, and that keeps the osmolality in the glomerular filtrate normal. And normal, that means isoosmotic, same as that of plasma. Okay. Secretions in the proximal tubule secretes some substances, important substances: PAH, penicillin, probenecid. These are the some pH. This can be used for estimation of renal plasma flow. Then penicillin is an antibiotic, probenecid inhibitor of penicillin secretion, and uric acid reabsorption, also inhibitor of uric acid reabsorption. Then urea. Urea is reabsorbed to some extent, and mostly urea is uh, excretable product. And urea reabsorption again participate in forming concentrated urine. And but mostly urea is a excretable product. Urea, which is produced from ammonia, is mostly eliminated through the kidneys. Creatinine is also excretable product that is produced from muscle creatinine. This creatinine is also excreted through the kidneys. Acetozolamide, a drug, carbonic anhydrase inhibitor, that is also secreted. And ultimately can be excreted. Okay. Reabsorption in the loops of Henle: 20% electrolyte, 10% water is reabsorbed in the loop of Henle, and descending limb is permeable to electrolyte water, ascending limb is impermeable to water. That's why the fluid that enters from the glomerular filtrate that enter into the descending limb of the family is isoosmotic. Is it clear? And hypoosmotic tubular fluid leave the loop of Henle. Is it clear? Because more electrolyte is reabsorbed, so hypoosmotic tubular fluid leave the loop of Henle. Okay. Reabsorption in distal tubule.